Hi, everyone. How you doing? It's great to be here. Thank you for being here. You all look great. My name is Daniel Roth. I'm a senior program manager on the ASP.NET team. And we're going to be talking about publishing and deploying ASP.NET Core applications in this session. Now, my purpose in this talk is not so much to show you every single possible way that you could deploy one of these applications. There's a myriad of technologies that you could use, lots of great solutions. You could deploy using Docker to the Azure Container Service. You could use Visual Studio Team Services. You can use Kudu in Azure. There's just lots and lots of ways that you can deploy an app. My purpose is more to give you a foundation in the key ideas, the key mechanics that are needed to actually get an ASP.NET Core app that you've developed and get it ready to be published and deployed into production. That's the goal. You've got an app. It's sitting on your dev box. You've been working on it. It's working great. What do you now need to do to the different runtime artifacts that are sitting on that dev box in order to get it into a production environment? What does that look like? And what is our sort of general guidance around what a production hosting environment would look like? So we're going to try and climb this cliff. That's the goal, and get our apps from development into production. Now, I'm also going to show you these things using very new bits. I installed a dev build of the .NET Core SDK, or the CLI, command line interface, last night. It all seems to be working, which is good. The reason why I'm doing that is because I want to give you as accurate depiction as possible of what this is going to look like when ASP.NET Core finally ships. It does look a little different with the newer bits than it does with the existing RC1 bits that you all have available to you right now. They've already been released. There's a lot that's very similar. But as much as possible, I'm going to try to show you deployment of an ASP.NET Core app using the new bits and the new gestures, and show you what those projects actually really look like. If you want to try this out yourself, if you love playing with fire like I do, the way you can do that, you can go to the .NET Core page. That's I think it's supposed to be a dot in there. It's actually .net.github.io. So I apologize for the typo. That's where you'll find the documentation and an installation link for grabbing the last known good build of the .NET Core SDK. There are actually much newer builds that you can get your hands on, and I recommend you do. That's what I installed last night. Those are available on their GitHub page at github.com/.net/CLI, CLI meaning command line interface. I'm also going to be showing you ASP.NET Core apps, sample apps that are running on top of the new .NET Core SDK. These sample apps are also available to you. They live in a CLI samples repo that's available in the ASP.NET org on GitHub. So you can clone that and try these out just like I'm doing. All right. It's really 3 simple steps to take an ASP.NET Core app and deploy it. There are different variants of these steps. There's different hosting environments that you can think about, and details in dealing with those. But at its core, the core mechanics don't really change. The first is you have an app. It's a bunch of source code. You're going to need to first get all of the package dependencies for that app. Imagine you have a Git repo sitting someplace. You clone it down. You've got all the code. You need to get all its dependencies, because you're going to need those binaries so that you can later publish the application. Second step is to publish the app. Now, publish in this context is a little different, I think, than the sort of classic notion of publish. You think publish like I published my book, I published my website. It's now available to the world at this point, right? In the .NET Core world, publish really means you're getting your app ready to be deployed. You're collecting all of the runtime artifacts that application needs in order to run and putting it all into a single folder, a single directory that you can then deploy using whatever technology you'd like. And that's the third step. How you then move that app into your hosting environment and how you set up that hosting environment, that's where the choices become quite broad. You can just copy the directory someplace. You could use web deploy as a technology. You could use Kudu and CI. You could use VSTS. There's a whole bunch of options here. I'll show you some of them. And I'll try and give you pointers to deeper dives into those different technologies that you would find useful for doing that deployment. But these are the 3 basic steps. You need to restore your dependencies. You need to publish the app in the .NET Core sense, which means collect all of its runtime artifacts, and then move that app to the hosting environment where you want it to actually run. Now, what does your app look like during development when you're using the .NET Core SDK? Well, there's really, in my mind, there's 3 key parts. The first part is there's the .NET Core SDK itself. That's the thing that actually has the core CLR, all of the base class library packages that come along with .NET Core, all the tools that you need to build, to restore, to pack packages if you're trying to create actual libraries as NuGet packages. That's all included in the .NET Core SDK, and that's typically installed centrally on your developer machine. You can also technically have side-by-side versions. Then you have your actual code, your application, your project code. Your project in the .NET Core world is defined by a project.json file. So you'll have your project.json files for as many projects as you have, your source code, static file content, any dynamic content you have, like Razor views, and any configuration data. That's usually sitting in some repo or some source code, source control system. Then lastly, you have all of your package dependencies that during development, they don't actually live in your application, in your project. They get installed centrally with .NET Core into a centralized place. Normally, it's actually in your user profile. And that place has changed folder names a couple of times. But in the .NET Core world right now, it's now a .NuGet folder that lives in your user profile. And that's so that every time you create a new project and start doing app development and start restoring packages, if you've already got those packages from a previous project, they've already been installed on your machine. You don't need to install them again. That makes development faster and easier, so you're not like creating multiple copies of the same packages over and over and over again. Now, when you then move to production, you want to publish this application, what needs to happen? Well, in a production environment, instead of having the full .NET Core SDK, you would just have .NET Core, the pieces that you need to actually run the application. You don't need to compile and build necessarily. You just need the CLR and the libraries. And that would be installed centrally in your production environment typically, although it doesn't have to. One of the nice things about .NET Core is that you can actually bring the entire thing with you in your application. That's also possible, and we'll talk about that. And then you actually need your published application. You've already run publish so that you've collected all the artifacts, the binaries from the packages that originally sat over in your user profile folder. You need to collect them up and put them into a single location so that your app can then run. Now, how do you do these steps? How do you move from that development environment to something that's ready to be run in production? Well, to restore the packages, you run .NET restore. Previously, in the DNX world and like the RC1 bits, you would run D&U restore. And in this new world, with the .NET Core SDK, you just run .NET restore, and that will pull down all the packages that your application needs. And initially, we'll install them typically in your user profile. Then to publish the application, you run the command .NET publish. That's what's going to figure out what all the pieces of those packages that your app actually needs to run. And it's going to collect it all into a single folder structure that you can then deploy. If you want to then run that application after you've deployed it, typically you then run .NET and the name of the assembly that was built during the publish step. Publish will do a build and the publish mechanics all in one go. The .NET command in your production environment will typically be on the path, like it's installed and it's available to you in that environment. So that's what you do. Well, let's take a look at what that really looks like in real life. So these are really, really new bits. This talk, I have more preview bits on my machine than I think I've ever had for a talk. So here I have a couple of applications. These are the sample apps that come from the CLI samples repo in the ASP.NET org. So you can get these right now and take a look at them yourself. I'm going to start looking at this Hello Web sample. This is just a very simple ASP.NET Core app. It just returns Hello World. It's only got one little piece of middleware sitting in its request handling pipeline that returns a string. Here's the program. Let's go to program CS file first. In my previous talk, I mentioned that ASP.NET Core apps, particularly in the .NET Core world, are just another console app. They really are. They have program main function, and that's the entry point to your application. And you have a little chunk of code in program main that uses the ASP.NET hosting APIs to set up your host and then get it started so it starts listening for requests. What this code is doing, it's creating a new web host builder. It's saying you want to use our server, Kestrel, as your server. It's saying the content root. This is basically the root of the application, this is not the root of your web root, where like your HTML and JavaScript files are, but this is actually the root of the app itself. The hosting configuration options are things like what port do you want to run on, where exactly is your web root for your application. This app is set up to also be hosted in IIS. We'll talk about that in just a bit. Which startup class you want to use to actually that defines the application that you want to run, and then you build the host and run it. Okay, so that's all this code is doing, and this code is virtually unchanged for all the samples that I'm showing you. It's basically boilerplate code. All right, project.json. What does this look like for the .NET Core application? Okay, first of all, in the dependencies section, you have this special package, Microsoft.NETCore.app. What is this package? This is a package that represents all of the packages, the base class library types and assemblies that are included with .NET Core when you install it. So you're saying that my app needs to be able to compile against the API surface area that's available with .NET Core. That's what that package is really doing for you. It has a special modifier on it that's type equals platform. What is that really doing? That's saying, even though I'm depending on this package, I don't want you to actually include the packages with my app. Like, I don't need all of .NET Core with me. I just need, conceptually, the reference assemblies, the API surface area, so that I can compile the application. The actual packages themselves, they'll already be there. They're installed with .NET Core, and they'll be available. But I need to be able to build, and I want to express that I'm building against that API set. This is kind of an interesting concept because it really is just a meta package in NuGet sense. And we can have potentially other packages like this that express even more. Like maybe I'm building against the entire ASP.NET Core API set, and you could have one that does that. But for now, this is the one that represents .NET Core. Then we have the packages that represent the server. And then lastly, down here at the bottom, we have our new target framework moniker. This is a .NET Core app. There's no longer any DNXs in this application because DNX is going away with the next release of ASP.NET Core. And so instead, you say, I'm creating a .NET Core application, version 1.0. What is this import statement? This is just a little piece of backwards compatibility. There are packages today that are built in a way that they're not compatible with the new target framework monikers that we're using. So to enable existing packages to more easily work with ASP.NET Core apps, this import statement says, even though this package says it doesn't technically work with the stuff I'm building for, it's OK. Go ahead and include it anyway. So that's what that's doing. It's a temporary thing. That'll go away as the ecosystem moves forward into the .NET Core world. All right, so that's project.json. So let's do our 3 steps. Let me open up a command prompt. And let's go to that directory. So documents, GitHub, CLI samples, hello web. OK, 3 steps, right? First, I need to restore my packages. So that's .NET Restore. Enter. Hold on. Before I hit enter, this app is configured to use the dev feeds for like the up to the minute packages that are coming out of the .NET CLI repo. And while I love our devs and I trust them completely, for the sake of simplicity, I'm going to actually just use my pre-installed packages. So I'm going to pass an additional parameter here that says, the only NuGet source that I want you to use are the ones that I've already installed on my in my user profile. So users diaroth .NuGet/packages. Now let me show you that folder actually really quick, because I think it's useful to understand how this works. So this is the folder. I've actually got a backup of some other packages in case I mess up. So here's all the packages that I've already installed on the machine. And every time you run restore on a project, they're all getting put into this single place. And if you've already got a package, the NuGet recognizes it and says, oh, you've already installed this version of this package. I don't need to go get it again. OK? So for restore, I'm just going to use the packages that are already installed. So that should go really quick and not be problematic at all, right? Yes, OK, great. So restore worked. I have all the dependencies I need now to run this application. OK, what was the second step? I need to publish. Actually, before I even get to publish, maybe I should just run the app so you can see what that looks like. To run a .NET Core app, you just run .NET Run. And that will build and actually run the application. So let's do that to make sure that, this is what I would do during development, right? I would be restoring my packages, installing new packages, and running it, and building it, and doing normal development. So let's make sure that's all working. And I should just see hello world here. All right, cool. So the app is a working app. Now, can I publish it? Yeah, let's just leave that. So Control-C. So .NET publish is the command that you will use to then publish the application. That should gather up all the assemblies from my user profile that are in the packages folder and everything that this app needs to actually run. Cool. Said it succeeded, and it said it put the published app in this published folder that lives under the bin directory for the project. So let's go look at what is actually there. I think the easiest way for me to get there is go digging through here. Here's that published folder. Let's reveal it in Explorer and take a look. What is this thing? So this is the build output, but the actual published app is just the stuff in this folder. I could literally copy this folder someplace else and run the app from just this folder structure. Let's go look inside. So I see a bunch of binaries. Most of these binaries are ASP.NET Core binaries. And then there's a bunch of these Microsoft extension binaries. This is the configuration system, the logging system, the DI system that we use in ASP.NET Core. And that's really it. There's not much else here. There's the actual built binary for my app. Now, there is this runtimes folder. What is that? Well, the idea with this app is that this app should be portable. Like, I should be able to take this folder and run it on a Mac, run it on a Windows machine, and that should be perfectly fine. And for the IL, that just works. But for the any native dependencies that this application has, well, you're going to need the native dependencies that actually work on that target platform. So what we do is when you publish the app, we collect all of the native dependencies for any packages that you happen to be referencing. The main one in this case is actually our web server. It's Kestrel, because Kestrel does have a native dependency. It uses libuv under the covers for handling HTTP requests. So if I go looking inside here, I expect to see there's libuv as the native DLL. Pop back up. That's really it. OK, and let's take a look at how big this is. It's not too big. It's about 3-4 megabytes of stuff for an app. And now let's see if we can actually run it like you would in a production environment. So if I go into the bin directory, into publish, the way I run this app is I write .NET and then the name of the assembly that was built, helloweb.dll. OK? And that should just work. And it's running. And let's see if that's going to, yep, and it refreshed. OK? So that's a running app. So that's a published application. You can now move it to your host however you'd like, whatever works for you. So that's option one. Let me go back here. Now, option two is you can do that app did not carry with it, I hope you noticed, like the CLR or any of the system dot whatever assemblies. Option two is you can have a completely self-contained application. In this case, the app carries everything with it that it needs, and it's all in one folder. You don't have to go to your ops guy or girl and tell them, like, can you please install .NET Core on my machine? I really, really want to use .NET Core. And like, no, we're not going to install anything for you. Instead, you can just bring all the bits along with you that you actually need. Now, .NET Core doesn't need to be pre-installed for this to work, and this can be useful in constrained environments. The output of a publish for an app that's written like this is now a native executable, and it's now platform specific. You will build like a Windows exe, or you'll build an executable that would run on a Mac or a Linux environment, and it just runs like a normal native exe. It's worth noting that your app will be substantially larger using this model, because you're literally bringing .NET Core along with you. Also, there's a performance concern, because normally when .NET Core gets pre-installed on a machine, we'll do things like pre-generate the native images for you. So startup is fast because you're not having to JIT things on the fly. If you're carrying everything with you, then you have to worry about those things. You've got all these system assemblies, and you have to, like, if you have to JIT all that stuff, that might take a while. So those are concerns that you'd have to handle. But let's take a look at what that looks like. OK, so for this, let's go look at Hello Web standalone. Now, the startup class looks exactly the same. Program CS looks exactly the same. Nothing's changed here. The only thing that's going to change is what I have in project.json. So I still have that reference to the libraries that ship with .NET Core. But now I've removed the type modifier. I really am depending on this package. I need it in order to get my app to run. I still have the dependencies on the servers. I'm still targeting, it's still a .NET Core application, so that's all fine. There's also a new thing at the bottom where I have to say, well, since I'm going to be generating a native executable for you, which ones do you want me to create? Like, do you want to run on Windows? Do you want to run on Mac? You have to list the set of runtimes that you actually want to work on. In this case, I'm just going to build for Windows. I know it says Win 7, but in this case, it's compatible, so it doesn't really matter. All right, so let's do the same 3 steps, right? So we pop out. So Hello Web standalone. Again, we need to run .NET Restore the safe way. Let's make sure everything's restored. Looks good. OK, now we need to publish. OK, and let's go take a look at what did that do. So bin, debug. Now I've got a runtime-specific folder, because this is the output of publish for that particular runtime. And there's the publish folder. And let's take a look. All right, publish. Now I've got a lot more stuff, right? This is all the guts of .NET Core. Somewhere in here is Core CLR. There's the Core CLR itself. That's the actual native CLR assembly. And instead of a just hello web standalone.dll, I now also have a .exe that I can just run. And then to run this app, I can just double click, because this is a native executable. It's completely self-contained. And there it up and starts. It's the same port, so hopefully it just returns hello world still, and it still does. OK? So that's what a standalone application looks like. It's much beefier. It's actually like about 10x bigger. Let's take a look. Yeah, this is like 50 megabytes now of stuff that you're carrying along with you. But it has that benefit of being completely self-contained. Well, one of the areas of innovation that we're looking at with the .NET Core SDK and the tool chain is that in the future, we'd like to be able to leverage technologies like .NET Native, where we can run this app through the like C++ compilers and really optimize it down to just one single binary that's much smaller and lighter weight that you could just carry along. That's not going to happen in V1, but that's something that we're looking at on our roadmap. So that's completely self-contained. The last option I want to show you for what does it mean to do the publish mechanics is publishing for the full .NET framework. You can use the .NET Core SDK to build an application that you want to run on the full .NET framework. That still works. We've supported that ever since we've been doing this ASP.NET Core project, and we will continue to support that. So what changes in this world, instead of targeting that I'm building a .NET Core app 1.0, you just say, I'm targeting .NET 4.6 or .NET 5, whatever version of the .NET framework you want that app to run on. It will still produce a native executable, so it still has that characteristic. And the nice thing about doing this is that all of your binary dependencies that you have today that work on the full .NET framework, they just continue to work, because you're literally going to run on the full .NET framework. .NET Core does have a bunch of API changes, so for binaries to work on .NET Core, they generally have to be recompiled against the new API surface area. Most of the code is unchanged, like 80% or so, depending on the code base, but it generally doesn't just run as is. So let me show you that real quick. OK. So I have a third app, which is this Hello Web Full. This has the same program CS, same startup CS. What's different in project.json? So in project.json, we no longer see that Microsoft Net Core app package, which had basically represented all the packages in .NET Core. Instead, we just have our 2 server packages. There is this Net Core Platforms package. And I asked the devs, what is that thing? And that thing has, it's complicated. No, that thing carries in it the runtime ID graph. Like, it understands, it has all the data that we need to understand how these runtime IDs should be processed. And that's really all it carries with it. So it's fancy voodoo to make restore and publish work is the best way to think about that thing. But you're not actually going to be using the .NET Core, the packages that come with .NET Core in this case, because you're just going to be using the binaries that come from the .NET framework, the things that are already in the GAC. Then we updated our target framework to say, I just want to target net 451 or net 46 or whatever you want. And then you still do need to specify which platforms you want to run for. What does it mean to target OS X in this case? Well, for example, this would work with Mono. If you wanted to build an exe that ran on Mono, you could do that by specifying the other platforms as well. All right, so let's do our 3 simple steps one more time. Hello web full. OK, restore. Great. Publish. Awesome. So now I should have a published app. What does this guy look like? OK. So this app, the output looks kind of similar to the first case, the sort of the default .NET Core application case, in that most of the binaries that are here are just the ASP.NET Core binaries and config and dependency injection and stuff. That's because most of the other BCL classes that you're using this app are just coming from the GAC. They're already installed in the machine as part of Windows. So you don't need to carry those with you. You're depending on the .NET framework being there, as opposed to .NET Core being there. But we do get a native exe in this case. This is a Windows exe. So to run this app, we can just double click. Oh, and that did not work. What did that say? Let me get. What about this? Oh yeah, do I have another one running? Oh, thank you. Yeah, the port was already in use. So because they're all running on the same port, and now it works just fine, and we can refresh the app, and it should be working. OK, so that's your third option, is targeting the full .NET framework. OK, that's really it. Now you just need to take that app and get it to your environment. Like, where do you want this thing to actually run? A word about hosting in production. Our guidance, we provide you a built-in web server. We give you Kestrel. But Kestrel is really not built, at least not at this point, to handle internet-facing traffic. Our guidance is that you should run Kestrel behind some sort of proxy that's going to handle all the crazy malformed headers or whatever that's going to come in off of the internet. Kestrel is not really built to do that at this point. So for security reasons and reliability reasons, we recommend running Kestrel behind some sort of proxy. If you're running on Windows, we would recommend using IIS. If you're running on Linux, you would run behind Nginx or HAProxy or whatever product that meets your needs. So your configuration would look like this. You have all that internet traffic hitting some sort of proxy that's forwarding requests to Kestrel, which then responds back through the proxy. That's the recommended setup. You can absolutely self-host Kestrel, but we recommend doing that more with trusted traffic. OK, so let's say you want to do this with IIS. If you're doing this on Windows, what does that look like? On IIS, the way we set up ASP.NET Core, the way we run ASP.NET Core in IIS, is using a native IIS module. Up till now, we had been using an existing module called the HTTP Platform Handler. And all this thing does is it takes requests and forwards them to a process of your choice. We have decided to fork the HTTP Platform Handler, and we've now created an ASP.NET Core specific module. We call it the ASP.NET Core module. And the reason we did that is because there were additional features that we wanted to get in there, and so we wanted to have control of the whole stack. So the new module, it's now available. The announcement issue that I've linked there, that's the announcement that said we're switching off of HTTP Platform Handler, moving to this new module. There are links in that issue that you can use to download the new module today, so you can try it out. It supports app offline, forwarding client certificates. It now supports IIS sub-applications, and it will handle also unlocking the config sections that are needed to configure the module. So that's now available. It's a new module. You set it up in web.config. This is the one of the few cases where web.config still lives. We don't use web.config in ASP.NET Core. When we're built on top of .NET Core, so in general, system configuration is not available on .NET Core. But IIS reads from web.config. So this web.config file is really for IIS purposes. Okay? And then you point IIS at the web root of your application, and away you go. You will need to configure the folder where your app lives to make sure that it has the right permissions so that the user that your IIS application is running as can access and execute the binaries. But other than that, it's pretty simple. So let's see what that looks like. OK, going back to Hello Web. So Hello Web, we need to use that new module. I've already installed the module on in the app. So what I did is I added a www root folder to the published output and added a web.config file there. So this is the configuration that you need to set up the ASP.NET Core module. It's pretty simple. You configure the module to point at the executable that you want it to run for each request. In this case, we want it to run .NET EXE. I believe you should be able to just specify your .NET Core installation on the path and run it that way. I couldn't get that to work. I don't know if I just didn't reboot my machine enough or whatever. But that technically should be possible. For now, I just, for the sake of the demo, I hard-coded the path. Then you need to specify the assembly that you want to run, in this case, helloweb.dll. And then that gets set up as a handler. It handles all past and all verbs. So it's literally going to forward all requests to .NET EXE running that particular binary. Now, this web.config file, I created it manually. We have built a IS publishing tool that you can plug into the publishing flow in order to generate this web.config for you, so you don't have to. Unfortunately, the tool's not working right now, so I had to do it manually. But the way that would look, just to show you what that will be like, here's a slightly more elaborate app. These are MVC applications. Down here at the bottom, you'll see there's a tool section that gets added in project.json. These are .NET tools that the .NET CLI knows how to find and knows how to execute. So they're cross-platform and I'll have those good characteristics. And then there's a script section in project.json where you can hook events that occur before or after publishing has occurred. So you can do some preparation or some modification of the published output. So here you can hook the post-publish event, run the publish IIS tool, and that will take care of generating the web.config file every single time you type .NET publish. It'll just happen. So that's the way we plan to set up like our project templates and applications once we ship RC2, and once that tool is actually working. It will be working soon. I think actually most of the devs that are working on it are here at the conference. You'll find them all in the lab. If you've gone to the ASP.NET Core lab, a lot of the proctors that are walking around there are actually the devs that work on the ASP.NET team. So make sure you say hi and thank them for all the good work that they do. So that will work eventually. For now, I just had to set it up manually. If you then go to IIS, I've already set up an application in IIS. I'm locally on my machine. Let's take a look at what that looks like. So I have this Hello Web app. Let's look at its settings. A couple things to note here. For the application pool, you don't need any .NET code, any managed code running in the application pool at all. So you can just create yourself an application pool that doesn't do anything with managed code. That's perfectly fine, because this thing's not going to be running the IL in your app. It's just going to be forwarding the request to some other process that will be doing that for you. OK? And then we point it to the physical path of the www root folder for your application. And you need to make sure the permissions for that folder are set up correctly so that IIS can read and execute code there. And that's it. So let's browse and see if this works. And so this is now running on IIS. So there's no port 5000, and it's going to get hello world again. So that's how you would set it up to run in an IIS-based environment. OK. From here, there's now a variety of cloud providers and deployment technologies that you could use. I'm going to highlight a few of them. I'm going to talk about publishing to Azure and what that looks like. If you watched Scott Hanselman's keynote talk yesterday, he showed he published an ASP.NET Core app to Amazon and to Azure and to Docker Cloud and had all running behind a traffic manager. All things are possible. Like, it's literally just a folder. Move it wherever you would like. But I'll show you a few of the simple cases, so just to get you started. So for publishing to Azure, we have direct support in Visual Studio for doing a publish. And you can publish to an Azure App Service really, really easily. That technology will use web deploy for moving the app from point A to point B, which is fine. And you can automate that deployment using there's a generated PowerShell script that gets set up whenever you set up an Azure publish from within Visual Studio. Alternatively, you can use more continuous integration-style deployments. Azure has a feature called Kudu, where you can, every time you push to a Git repo, then it can kick off a deployment on Azure. And then what happens is there's literally a repo over on Azure there where you've pushed your updated code, and you have a deployment script, like a deploy.cmd file that kicks off and does the three magic steps. It will restore the packages, it will run a publish, and then move the publish app into the actual Azure website that you set up. There's similar functionality available in VSTS, where you can set up a build flow and a publish flow into Azure. The deploy script for Kudu right now works with RC1. It does have some issues. If you try to do it on a free tier of an Azure App Service, it will run out of disk space. We are working on that, so that will no longer be the issue. To work around it, you can upgrade to a basic app service, and that will work just fine. All right, let's see publishing to Azure. And we'll talk through some of the extensibility points that you can leverage. All right, let me go to Visual Studio. Here I have MVC, ASP.NET Core MVC app that I would like to publish to Azure. The way you would do this, let me make some change here so that we know that this is real, that I didn't just already publish this. Let's go to index, web deployed at build. How about that? OK? Great. Now we're going to publish. And I can just do a right-click publish. And I can select that I want to do, publish to an Azure app service. You select your subscription. You can actually go ahead and create the Azure the website directly here from within the tooling. I don't think those are the right ones. There we go. I've got a bunch already. Why does it keep switching back? I want to see the ones from my subscription. OK, now don't move. Good. OK, so here I have a bunch of websites that are already set up. I'm going to publish to, which one? I think this ASP.NET Core website is the one I'm going to publish to. I've already set that up, so I'm going to select my existing publishing profile that I've already created. And let's go ahead and publish. We'll give that a second. So it's going to do a build, and it's going to do a publish locally on my machine, and then use web deploy to push the published application all the way up to Azure. And it'll pop up the browser, and hopefully we'll see the result in just a minute. While it's working on that, and you're welcome to watch the text output, but let's look at something else in the meantime. If we go looking in the publishing profiles folder that Visual Studio generated when you said you wanted to publish to Azure, one thing that's kind of nice is it generated this PowerShell script that's actually used as part of the publishing pipeline to get that app up into Azure. The work, this code looks a little bit complicated, but most of this code, there it is. OK, so we're just popping up the browser like, whoa, popping up the browser for me. This is the app's now starting up. And we hopefully will see web deployed at build. A little cold start performance. It's going to do that. I believe. Have faith. And oh shoot, I'm gonna. How come there's no back button? ASP.NET, this one, right? There it is. And we web deployed at build. OK, cool. So that worked. It's pretty simple. If we look at the PowerShell script, most of what this is doing is actually just grabbing the PowerShell modules that it uses to do the actual deploy so that they don't have to be available on the machine when you actually run the script. The real brunt of the work happens down here at this publish ASP.NET call using this publish ASP.NET module. It's a module that's available on NuGet that you can just use. So if you want to extend what happens during that publish, you can just add some logic in PowerShell before or after this call, and that would work just fine. You can then script it. You can automate it by running MS-build and invoking the particular task to publish the application to Azure from the command line. That does work. Alternatively, instead of modifying the PowerShell script, you can just go right into project.json, and down in the script section, you can hook those events. And the templates actually by default are doing this. Like before you publish, our default templates will run an npm install, Bower install, and they'll use a bunch of gulp tasks in order to minimize and bundle your scripts and style sheets that are in your application. And that actually happened if we went back in the output somewhere in here. Well, I'm not going to try and take it up, but it would actually tell you like I'm running npm now and I'm running these gulp tasks. OK, So that's doing it with web deploy from within VS or from the command line. That would work too. Let's try doing kudu. There's actually a lab that will walk you through doing a kudu style deployment here at Build. So here's another application. As you can see, I've been adding more and more excitement to this application as time goes on, every time I've tried out to publish. So to set up kudu, what you do is you're going to go to your subscription on Azure, and you're going to create an Azure app service, and you're going to specify the deployment source to be whatever Git repo you want. It can be on Bitbucket or whatever. In this case, I just used a local Git repository on my machine, and I then push to kudu directly. And you can see I've done a bunch of deployments already. Let's create a new one. So to do that, I guess, that's a lot of excitement already. Hello build, let's say that, from kudu. And I'm going to save it. And so what I do here is I need to now commit to my local Git repository. I'll use Visual Studio to help me do that. You could do this all from the command line as well. But for people who like to click, from build, and let's commit that to my local Git repo. Cool. If I go over here and look at my settings for my local repo, you'll see that I have a remote set up. If you're not super familiar with Git, a remote is the URL of a repo that you sometimes want to be able to interact with, like pull and push changes from. And you can see I've set up a remote for the Git repo on kudu. And you can see that over here. Here for this ASP.NET Core Kudu web app. There's the Git URL right there that you use. Okay, so I've already set that up. Let's now sync the change up to kudu. So going up to Azure. Let's sync. And this part I'm just going to do from the command line. So git remote will show me the remote name. OK, ASP.NET Core Kudu. That's what I need to push to. So git push to ASP.NET Core Kudu. The master branch, which is what I committed to. Okay, this should ask me for a password. It does, because not everyone is allowed to push to my kudu deployed app. All right, now what is this going to do? Now this will take a little while, because all I did was push the code up there. Kudu is now going to take care of restoring packages and building and publishing, and it's doing it normally on a fairly clean environment, so it's restoring all the packages. So this can take a little time. Just to show you exactly what it does, let me go over here, and I'll show you the actual script. So this is on the kudu GitHub repo. This is literally the deploy CMD file that kudu uses to deploy your app. Now, with kudu, you can create your own deploy CMD files and do whatever you want. They just happen to already recognize an ASP.NET Core app and then use this built-in deploy CMD file for you on your behalf. And what does this thing do? Well, there's a bunch of stuff here at the top that's really just acquiring DNX. Because I'm actually using DNX in this particular case. I'm not using the new .NET Core stuff. The new .NET Core stuff doesn't work, unfortunately, in kudu yet, but we're actually busy working on fixing it right now. So it acquires DNX, but then down here, notice it's doing the same steps. It's going to do a restore, it's going to do a publish, and then this kudu sync call is what's then moving the published app over into the actual Azure website. Let's see, is that done? Oh, it finished. OK, great. That wasn't too bad. ASP.NET Core Kudu.azurewebsites.net. And this should say from build, hopefully. A little bit of startup perf time again. There it is. OK, hello from build. OK, so that's a kudu style deployment. You can use that as a way of doing CI. All right. What else can we do? What if you want to publish to Linux? What if you don't want to publish to a Windows environment? How can you do that? ASP.NET Core is cross-platform. It runs on top of .NET Core, which is cross-platform. If you're running on Linux, a really compelling solution to use is to use Docker containers. If you don't know Docker, don't freak out. That's fine. Docker is a very lightweight container technology. You can take a piece of software and put it in a Docker container, and it gets its own little file system, its own little OS world, kind of. It actually will. It's a much lighter container technology than a full VM because it will reuse a bunch of the OS stuff from the host that that container is being run on. So you can actually start and stop a Docker container in seconds as opposed to the many minutes that it would take to boot up a VM or shut down a VM. So it's very lightweight, but it gives you a nice level of isolation and consistency. Because then once you've put your app into a Docker container, you can specify exactly how you want that container to be set up. And then you can just build an image for that container and deploy it. And you now know that you're running in a consistent environment, as opposed to constantly publishing new versions of your app to an existing environment. And every time you might be dirtying the environment, and then you don't really know what's happening. It might be some stuff that got left behind that messes up your application. Docker can insulate you from that. And they have all sorts of wonderful other features. You can create images and share them on a centralized Docker hub. So you can go find interesting images and then layer additional logic on top of it. It's a pretty cool technology that has some resiliency features built into it as well. Great. So we can run ASP.NET Core in Docker. How can we do that? Well, first of all, we have ASP.NET Core images available on the Docker Hub that you can just use. They're already set up with, and currently they're set up with DNX. We will have .NET Core-based images coming soon. They actually might already be available. I think they might actually already be available. So those are out there. I'm going to use the ASP.NET Core ones for today, just because I'm using RC1 bits. There's tooling that you can get so that you can create a Docker host on your development machine. You need a host that will actually run the containers. And Docker today is primarily Linux, although Windows is ramping up its container story as well, and you'll be able to run Docker Windows-based containers as well. The Docker guys have published tooling for both Mac and Windows. And what it will do is it will create a nice little VM for you on your machine and set it up as a Docker host and make it really easy for you to then put images in that host and run them as containers. There's also the Visual Studio tools for Docker, which make it really easy for you to take an app that you have in Visual Studio, enable it so that it is built as a Docker image. And then you can then, on F5, they set up a bunch of MS build tasks so that it will publish to your Docker host, and then you can have your app running locally in a little, like a Linux VM or Windows, in the future Windows VM, running in a Docker container. So that's pretty cool. And then lastly, having a single image that you just run in a host, that's cool and it's interesting and useful. Typically, though, for large distributed applications, you're actually going to want to have like a whole bunch of containers running and clusters of containers on different VMs. And as they fail or as they're no longer needed, you might want to move them around. That's where this whole world of Docker container orchestration comes into play. And there are a lot of technologies that you can use to do that. Apache Mesos and Docker Swarm, thank you. And we have a nice service available for you on Azure where you can set up your own clusters really easily to do that. I'm not going to show that in much detail here, or in any detail actually, but there was a great talk actually that happened earlier this week that you can go watch the recording for that goes into great detail about the Azure Container Service. But let's play around with Docker a little bit now. All right. So let's open up a new application. This is an app that we want to deploy to Linux in a Docker container. Now, I've already installed a version of the Visual Studio Docker tools, so those are available to me. I've also already installed Docker for Windows from the Docker guys. Now, that Docker for Windows is a limited beta, so you have to go to the link and you can sign up to get it. But it's pretty cool stuff. What it will do is when you run it, you'll get this little, I think they call it a Moby, a little whale that's running down here in the corner. It's I don't know why it keeps getting in the way. But it's telling me that Docker is running on my machine. If I were to go look at Hyper-V, what's really happening there? When I installed Docker for Windows, it actually set up for me this little tiny Linux VM, and it set it up as a Docker host, and it's just running. And now I can interact with it using the Docker tools, and I can publish applications to it. To publish applications to it, the Visual Studio tools make that really easy. So what I did with this application is you can right-click on an application, and you can say, I want to add Docker support to existing application. And then we'll add the MS build tasks and Docker files and Docker compose files to your app so that you can now, on build, create a Docker image, and also on run, move it over into a Docker host that you set up and run it in that host, in a container. Now, I've already done that. It's really quick to do, but I've already set it up. What did that actually create for me? In this Docker folder, I now have my Docker files. If we go look at this files, this is kind of like a script that layers like a cake in order to set up to specify how you want your image to be built. Now, at the top, it says from, and then it specifies an identifier for an existing image on the Docker hub. And this is the ASP.NET Core Docker image that I'm going to use as sort of the base layer for the image for my app. And then on top of that, you then run additional commands, and each line really creates a new layer in the image. And as you rebuild that image, if you haven't changed anything that affects that line, it gets cached and it doesn't need to be rebuilt. So it's pretty smart. But this is pretty simple. It's just going to copy the app in. It's going to run a restore, and then run the application within the image. So let's try that. So literally, all we need to do is, if this works, is Control F5. All right, so build is started. OK, a little command prompt starting off. Opening site, and I think I have a little problem that I had too many containers. Well, actually, that looks like that actually works. So I published into a container. It wasn't able. I don't know if you saw the text there. It was actually trying to stop any containers that were running on the same port. It ran into a little issue there due to a bug with when you have multiple containers that were there previously. But it was able to then move the image into the container, and this is now running inside of Docker. If I I think if I do this, Docker PS. This will ask the current host on my machine running in that little VM image, what are the Docker processes that are running? And there you can see there's a little app that's been up for only 40 seconds that I just deployed. So that's running locally. This would be your developer flow. You edit your code. You can then build an image and see it running on your machine. What if I now want to run this in Azure? Like I want to take this app and now deploy it. Because this talk is about deployment, not about development. There's a lot of cool stuff with development, though. Like you can debug into that container. It's pretty sweet. To deploy this application, what I've already done is I ran a tool. There's a tool called Docker Machine. I used a version of Docker Machine that can create a Linux VM for me on Azure that is already pre-configured with a Docker host. Let's go look at that. Okay, resources. Actually, I think it's right here. Let's go right here. So this Azure Docker host, this is a Linux VM that's running a Docker host that's set up for me to publish images to. And then I can use this Docker machine command to remotely interact with that host. Now, when I enabled Docker for this application, it actually created a PowerShell script that automates a lot of the tasks that you would normally do with Docker machine. If I go looking in this Docker task.ps1, this is a really nice script that lets you build and run images in any host that you've set up with Docker machine. Now I've set it up to, I'm going to point it at that Azure Docker host and ask it to build my image over there and then also run it. Let's give that a try. So I'm going to do this all in PowerShell because this is a PowerShell script. I'm going to use this little script that the Docker Visual Studio Tools created for me. So let's go into Visual Studio 14, and then this app was ASP.NET Core Docker test, right? And let's go into my project folder. OK. Now I'm going to run that Docker task script. So Docker task PS1, I think is what it was. There it is. I'm going to pass this a couple of parameters. First thing I'm going to do is I'm going to ask it to build. And I want it to specifically build the release version of my image. You notice that I had both a debug and release version of the Docker file. I'm going to ask it to do the release version. And then I'm going to tell it which host I want it to do this on. And I'm going to tell it to do it on my Azure Docker host, I think was the name. Did I get that right? The Azure Docker host. OK, so build. All right, so it's saying it's now building. Move my code up there. You can see all the layers of my Docker file being represented there. It didn't have to change things that it already built before, so that all looked just fine. You know, did I change anything? Did I change anything in this app to like make it unique? Maybe that's why it was so fast, because it was already all pre-built. Let's add hello build from Docker on Azure. OK, let's do that again. Let's make sure it actually does something different, because copy the app. OK, so a little bit more there. All right, cool. Now let's run it. So the only thing I'm going to do to change to run it is I'm going to switch from build to run. And let's see how that works. So if there's any existing running containers that I have there, and I had an app that was already running there, it'll stop it, and then fire up the new image as a container. There's the container ID. It's recreating the app, opening now it's opening up the browser locally for me, and that's the IP address of my VM over in Azure that I've already opened the ports for, and hello build from Docker in Azure. OK, so that is a containerized ASP.NET Core app, running in a Docker container on a Linux VM with a Docker host hosted on Azure. That's just one little container. Like normally for a big app, you'd want to have a real orchestration system around that thing. That's when we'd use something like the Azure Container Service. But this at least shows the idea that you can publish ASP.NET Core apps on Linux using Docker. All right, I also got to give a little plug to the Service Fabric guys. Service Fabric is a nice platform for building microservices, again, in isolation with resiliency. A lot of similarities, I think, honestly, to what the Docker guys are doing, except they have some additional features that I think are really, really nice. They have a nice API for doing application development. They support both stateful and stateless services in their platform. So they are also a great place to run ASP.NET Core services and applications. If you heard in one of the keynotes, the guys doing Age of Ascent, they're using ASP.NET Core because they love the perf. They're using Service Fabric to handle their scale out and reliability for this massively multiplayer game. So this is a great place to run your apps, and you'll see more like templates and first-class tooling support for this coming in the future as we stabilize and release ASP.NET Core. All right. So I hope you've seen that at its heart, deployment with ASP.NET Core is really simple. It's just three things. You restore, you publish, and then you move your app to wherever you want it to actually run in a hosting environment that you've set up. I hope you enjoyed learning about deployment of ASP.NET Core. There's a bunch of links here that I would point you to learn more about specific environments. Like if you want to learn about ACS, there's a great talk here at Build. If you want to learn more about Azure Service Fabric, there's a couple great talks that are here at Build as well. And you can learn how you can deploy your apps specifically into those environments. And thank you, everyone, for coming. Please join us with ASP.NET Core. Meet our docs.
I have a question. Right here?
Sure. Well, I can't see. Where are you? Over there. Hello.
Yeah. Since ASP.NET Core is very modular and the applications run in process in a console application, are they possible to include in a WPF or UDP application to facilitate cross-process communication in a local application suite?
That's a great question. I don't know. I think so. It should be. Like you can target like full desktop with one of these applications, and you can, like our packages, they'll say that they support both running on .NET Core, and they also say, I'm just also a package that can run on any full desktop application. Right. So I believe the answer is yes, but I haven't actually tried it or tested it myself, so I'm a little hesitant to say absolutely, but I believe the answer is yes.
It got me really excited, just seeing that it runs in a console application, because there's been several times I've wanted to facilitate cross-process communication, and it's just, you have to have a server and
absolutely, whatnot. Yeah, so. And you get the whole web stack in this case. Yeah. You get everything that we can do in ASP.NET Core, you can run on top of that web host.
Yep. All right, thank you.
Yeah.